Greetings again. This is Dr. Schreifels trying to give you another video to help you understand stoichiometry. In this video we're going to be given the moles of one of the reactant, and from that we're supposed to figure out the moles of the product. So we start with the same concept that we had in the last video, which says that the molar ratios of reactant and product should be equal to the ratio of the stoichiometric coefficients. So in this problem here, we want to figure out how much ammonia we will produce if we start out with 10 moles of hydrogen and a large excess of N2, so that the amount of hydrogen that is available will limit how much ammonia you can have. So we define our variables again. So we start out with nitrogen. I'm sorry, not nitrogen, because that's in a large excess. We're going to define H2 as the number of moles of H2, which in this case is 10. And then we don't know the number of moles of NH3, but we will call that N of NH3. So that's what we're trying to figure out. So fairly straightforward for this kind of a problem. So we're going to take the ratio of these two quantities here. Since we want to solve for the number of moles of ammonia, let's put that on top. So N of NH3 over N of H2. And remember, I said that it must be equal to the ratio of the stoichiometric coefficients for those compounds. So if ammonia is on top, the coefficient should be on top. So 2 moles of NH3 are produced when you have 3 moles of H2. Of course, now we can put in, let's rearrange this. NH3 here, sorry for that, equals N of H2 times 2 over 3. Now we can put in our 10 moles of H2 and 2 over 3 for the ratio of the coefficients. Now, if you followed the units through, even though I didn't write them down, if you follow the units through, you'll see that the result is the moles of NH3, which in this case is 6.67 moles of NH3. So that's our first problem. And we'll do another one just so we can practice. So here we're making NH3, that's nitric acid if you're interested. So we're told we have oxygen present and a large excess of the hydrogen and nitrogen. So we have 15 moles of oxygen. Same exact strategy. Since we want to, let's say N of HNO3 is the number of moles of that, and we're going to divide that by the number of moles of O2. And from what we said before, we have to take the ratio of the stoichiometric coefficients. So HNO3 is on top on the left side, so we have to have it on the right side, so that's the 2. And 3 is the coefficient for oxygen. Solve this for the R unknown. You can see why I put N of HNO3 on top, because when we rearrange that, it's fairly straightforward to just bring the moles of O2 to the other side, like that. And then we can put in our number. for oxygen, 15 moles of oxygen. Let me put the units back in just so we can, moles of NH3 per 3 moles of O2. So you can see the moles of O2 will cancel, and you'll be given the units here. For the right side will be moles of NH3, which is of course what you expect to have. So of course we can do the math for that, and of course you get 10.0 moles of NH3. I hope that makes things a little clearer on how to do things if you are given the moles of reactant and you have to figure out the moles of product. Talk to you later.